Today we are going to see one new scenario, and let's see what is the scenario. Deploy the highly available application using the Kubernetes replication controller. Okay, so today's scenario is DevOps team is stabilizing a replication controller to deploy the multiple pods for hosting the application that require a highly available infrastructures. Following are the specifications below to create the replication controller. Create a replication controller using the Nginx image with the latest tag and name the Nginx replication controller. Assign the label app as the Nginx app and type as the front end. Ensure that container name is the Nginx container and set the replica count to 3. All the pods should be running a state post deployment. So this is the our today requirement. So first let's see what is the replication controller. A replication controller is a Kubernetes object that ensure a fixed number of a pod replica are running. Okay, and automatically create a new pod if some fail or deleted. Okay, so in short, replication control makes sure the particular number of a pod in the deployment or replica set is running always. If at for any reason, if some pod deleted or in the failed state, it will be trigger the new pod. Okay, use the label selector to manage the pod and its control. Note: replication controller are largely been replaced by the deployment and replica set, which offer more advanced features like rolling update and rollback. So, in the previous version of Kubernetes, the replication controller are used, but now in the latest version of Kubernetes, deployment and replica set has replaced the replication controller, which has the more advanced feature like rolling upgrade and rollback. So what is the use case of the replication controller? The first one is a high availability. Ensure the multiple instance of application are always running. This is the one use case. Second one is fault tolerance. Automatically replace the failed pod. If one pod down, then it will trigger the second pod. Third one is load distribution. Help distribute the traffic across the multiple replicas. So it also help if the traffic are coming and it has the multiple replica pod, then it will distribute equally to all the pod. And the last one, legacy support, still used in the older Kubernetes setup and backward compatibility. So still its replication controller are used in the old version of the Kubernetes. Now let's see what is difference between the replication controller and our current replica set. So first one is the label selector. Replication controller exact match only, means whatever defined in the replication controller, it will be match with that one only, but in replica set it will be support set base. Means if like a star gives something like Raj dot star, then it will select all the Raj dot star. Rolling updates. Replication controller does not support the rolling updates, but replica set support via the deployment. Preferred usage, replication controller used by the legacy is older version, and the replica set is used by the newer version. So now let's come to our scenario what to be defined here for the replication controller. So let's see the YAML file for that one. So API version of the replication controller is V1 only. Kind is replication controller. In metadata, we have given the name replication, Nginx replication controller. Then we have the two labels as per our requirement. Label equal to Nginx app and type equal to front end. Then the in aspects part, we have the requirement of three replicas so that it always the three replica pod. Then selector, by the help of this selector only, the pod is going to define. We have the app equal to Nginx app, type equal to front end, and then template of the pod. in metadata we have the labels, same labels whatever we would define, and app equal to nginx app and type equal to front end. And a specs part of the container we define the container name, then image used by the container nginx latest, and then port of the containers. Then we are going to deploy this replication controller by the help of kubectl apply -f port.yml. Then replication controller will be created. We can verify by the same kubectl get replication controller. Then it will be see the replication controller created and 3 pod. Same thing we can define verify by the kubectl go pod. Then we can see all the 3 replication controller pod are in running state. So let's see same thing in our production clusters. Let's copy the our YAML file. Just copy it, and this is our production cluster. Create one file by using the vi editor vi pod.yml. You can give any name, not an issue. Then open it, open in edit mode, just paste it. Then this we already explained, and just save it, except colon wq. Then just create it kubectl apply -n, then pod.yml, then press enter. Then our application controller is created. Now let's check our application controller whether created or not. Then we can run the kubectl get replication controller. So we can see the replication controller are created with the desired 3 port, current is 3 and ready is 3. Same thing we can confirm by the kubectl get ports. So we can see all the 3 ports are in running state. So in this way we can create the replication controller for a high ability, and all the step and every information we have given in our blog, and blog link I will be attached in the resource part of this lecture. Thank you and happy learning. See you in the next video.